Thank you so much for coming. So I'm Brianna Montgomery, and I lead business development for ConsenSys Diligence. And then I'm joined with Sergii here, and he's one of our security auditors and engineers. So our talk today is going to be on auditing and why do we audit. If everyone went to Vitalik's talk this morning, he spoke about the importance of auditing and how he would love to see more in the ecosystem and how internal vigilance is super important. Security auditing is a part of that as we scale. So why do security auditors wake up every morning? It's because they're passionate about creating a safer and more trustworthy environment, as well as aiding in the development of the new era of the internet. So what is an audit? We get asked this very often, what's included in the audit process. So essentially, an audit is an assessment of your secure development process, and it's an opportunity to learn from experts and identify gaps in your processes. Before an audit, we ask that the code is frozen for most situations because it's really difficult to audit a moving target. So the process starts with the code freeze, and then we will run it through some of our internal tools, and we will put together an initial report after the manual review that includes security recommendations, general recommendations, and any vulnerabilities that we find. And then typically auditors will work with you through the mitigation stage and then publish a final report and tell you so you can use for your users, your investors, just so they know that you are taking security seriously. So our talk two is mostly about vulnerabilities and the cool things that we've found. So I'm going to turn it over to Sergii, who's going to talk through some.
Hello, everyone. Can you hear me well? Yeah, hope so. Okay, so first of all, we'd like to share a common vulnerabilities that we usually find in our smart contracts audits. Some of them are also common for like traditional software security. Every software developer knows about them. So it's like mostly underflow or overflow of variables, lack of input validation, or for example, uninitialized some software component, which is in smart contract case, uninitialized storage. For example, like everybody of you might know about parity frozen ETH hack, where lots and lots of ETH were frozen in parity wallets because library was not initialized, and somebody just initialized it and destroyed it. Of course, it's just one more traditional common vulnerability is logical bugs. You cannot really categorize it to anything. All of them are unique and like goes from audit to audit, but you can have like from critical to minor like logical problems. On the other hand, we have lots of smart contract specific vulnerabilities. And I wanted to share like some list of them. It's not a full list, but it's like some of the most interesting and like common them. It's sometimes really hard for new smart contract developers who came from traditional software development domain to keep in mind all of them, especially because lots of our, not only our, but lots of projects in Ethereum ecosystem does not have dedicated smart contracts developers, so they have like backend or front-end developer who are doing smart contracts development in their free time, like not a free time but extra, and so they are not that experienced at it yet. So one of the most interesting vector of attacks is a reentrancy attack. This is a kind of attack where your smart contracts call another smart contract, and in that while doing so, second smart contract can call first one again while creating this call loop inside one transaction. This is really unexpected behavior like in traditional software development. One of the most interesting examples of that, and most famous one, is a DAO hack where lots of funds were stolen and it caused Ethereum hard fork. This is very tricky attack because sometimes it's really hard to identify, but it's even much harder to actually understand if it can be used maliciously by somebody or it's just intended behavior, because sometimes it is intended behavior, like in some voting contracts, for example. And another thing is front running. It is also very common for blockchain because all of the transactions, they are visible to everybody, they're public, and anyone can read it. Anyone, if that makes sense, if that may bring some value, anybody can create the same transaction but from their address, and put a higher gas price on it, and then it will most likely be executed previously before your transaction. Uh, so it's I would say software developers, like smart contract developers, are responsible for creating front-running protection for their clients. Uh, it's also a very common problem, like trusted actors or trust model. So sometimes intended trust model does not correspond to the implementation. So that's what we usually find and have like lots of bugs about it. Um, because sometimes systems should be totally trustless and non-custodial, but there are some admin modifiers, some admin functions that allows you to either block everything or steal funds or do something like that. Or, for example, make some advantage to one user while disabling this advantage from another user. Another thing is upgradability. So smart contracts are not upgradable by default. That's why it's should be audited properly, because if there is bug in it and like lots of money, then you should not have problems with that. You don't want to have it. So usually lots of projects want to have some kind of upgradability mechanisms, and sometimes it either breaks trust model, because as an admin you can change it, you can make system more centralized or something like that. Or it can just break some functionality. One more interesting stuff that's happening is like having everything with proxy or delegate calls. Delegate call is a option to execute code from another smart contract, but in the first smart contract's storage in its context. So sometimes it may result in really unexpected behavior. Now I want to share you what's one of the most interesting attacks that we found recently is Uniswap reentrancy attack. As you might know, Uniswap is like a protocol for automated token exchange on Ethereum. It stores equally ETH and tokens in the liquidity pools, and everybody can invest in a token ETH pair that they want to. What was tricky about this audit is that when we started it, it had already been live on the main network and it already had funded liquidity pools. So like if you find some bugs, it's kind of tricky to fix it and to secure all the funds. So about the bug itself, like you can see on the small picture, like we have our report. If you want to like see all the technical details, you can go there, or we have a blog post about it. I'm not. I didn't plan to be like super technical here, but the main thing is that some of ERC20 compatible tokens may allow reentrancy. For example, ERC777, which is like more advanced ERC20 with different hooks. So it allows you, so on token transfer, it calls both sender and receiver of the tokens. Or for example, some kind of security tokens or regulated tokens have some controller that's also like separate contracts that check something, whitelisting, KYC, anything, or even any other custom implementations of smart contracts that we even don't know about. So these are some kind of ERC20 compatible tokens that can allow reentrancy. And exchange functions did not have any reentrancy protection. So like the attack vector is kind of simple. You want to buy, for example, something. You do reentrancy when you transfer tokens. Prices are not upgraded yet, are not updated yet, and the second buy will be with a better price for you because it hasn't went up yet. So while doing that, you can do the opposite transaction after with the good prices. So the difference will be actually profitable for you, and you will just earn free money. By doing that many times or with big funds, you can just drain all the liquidity pool from this particular ETH to token pair. To be clear, if token is simple ERC20 token, if it does not allow some specific kind of reentrancy that is needed here, like you cannot use this attack for that liquidity pool. The next one. The problem with this bug is that it requires like broad knowledge of how token is designed, ERC20 standard, and like all the future possible standards that are built in on top of ERC20 and like being ERC20 compatible. It's very hard to anticipate when writing tests or running security tools. It also was tricky for us because we scanned all existing tokens for major liquidity pools in Uniswap. So we like had like top liquidity pools that have like all the funds that were stealing, and we looked through all the code from all the tokens to understand whether funds were safe or not. It appeared that all the current funds were safe, so it was not like a major breach of Uniswap. What the situation can actually teach us. We should all know, as a smart contract developers, that ERC20 token should not be considered as safe against reentrancy attacks. Uh, and additionally, any kind of smart contracts that you do not control, that you did not audit, and you didn't write it, should be considered as like reentrancy possible. So for any reentrancy sensitive function, you should add reentrancy protection, which is pretty easy, and not only to the functions that has external calls inside, but also to all relevant functions that can be used as a second call. Uh, Also, be careful when using or like deploying new types of tokens. So if you are a startup deploying your C777, you should also consider that there might be some projects out there that just do not have reentrancy protection because they did not work on it enough. And that is not what you would want to do, because you will not want to have your tokens stolen. And of course, always have an emergency plan. No matter how secure code is, you should still know what to do if something goes wrong and if it's if there is some bugs in your project. Also, blockchain security is a moving target. Ethereum is always evolving. It's always changing. We have new hard forks coming. That's changing something that some of our assumptions that we considered are immutable. This is just a few examples, not a full list. For example, the fact that gas cost may be changed because it's bounded to the resources that is needed to actually execute everything. I just put it two EAPs that had like huge discussion among the security people in Ethereum. The first one is EAP 8184. It's most likely going to happen soon on the next hard fork. One of the points in this EAP is that like S-load operation is gonna cost a little bit more, and the problem about it is that it may break some already existing smart contracts on mainnet. But it's still gonna be happening, as far as I know, for the current moment. Next AP is 1283. It's hopefully it's rejected from the previous hard fork. It should have decreased gas cost of store operation in some cases when you're modifying something, not like creating a new variable. The problem with that is that it could allow reentrancy and state or state changes inside normal transfer or send function, which was not the case previously, and every smart contracts developers assume that these functions are safe from reentrancy and any kind of state changes. So the main idea of that is that gas cost can be changed, and it will most likely be changed. So smart contracts developers should not think about gas cost as something immutable, and should not be bounded to that. One more interesting thing that's changing in Ethereum is like creating new opcodes. EAP 1014 is already implemented, and we have create 2 opcode. This is interesting kind of opcode that allows you to create smart contracts with more predictable address. This is done for counterfactual, creating counterfactual smart contracts, which means that they are not deployed yet, but you know their address like way before they can be deployed. The problem with that is that it may be used to replace an old contract with a new one with different code, but with the same address. This was also considered as impossible before that. So all these assumptions are always changing, and you should be always check all the latest changes and be ready for them. I think we're running out of time soon, so it was really nice to meet you here. And if you have some other questions or like wanna reach out to us, this is our contacts. And if you have questions right now, please. So the question is, do you want to have like continuous audits if if Ethereum is changing, right? Or if your contract is changing, because it's okay.
It depends per client.
Yeah. So sometimes our clients have like modular system or something. They have like big systems, and they are creating new modules. So the idea for that is like they have initial audit for their full system, and then when they deploy new modules, upgrade it, they have like smaller audits. If upgrade of the system is major, like version 1, version 2, we're just changing all the system, it's like full re-audit. But if it's like just new modules, you can add just small portions. So every code should, like, all the code should be audited. Sometimes you can only change the code, only audit the difference, but sometimes you need like full re-audit for that. Yeah, about the change in Ethereum, it's a really nice question. I think you can also analyze the system if it's if it's vulnerable to new changes. Like here, for example, gas cost. Like in this slide, gas cost of a slot operation may be increased, and you might have smart contracts that is dependent on that. So if you feel like it might affect you, you should reach out to some auditors and actually have it audited. Yeah, like for this particular thing. Yeah. Okay, how to avoid front running? It's usually like the most primitive one is commit reveal scheme. So if you want to send some transaction with some data, first you send like encoded data, like hash of this data, and then the system will write that this hash belongs to you as a sender, and then you write revealed one on the next block. And if somebody would want to front run you, he will go to smart contract, and in smart contract it will be written that this hash is already claimed by you, so nobody would be able to front run you in that case. So this is like the simplest and like pretty good way how to do it. Any other?
Thank you for the speech. Okay. Could you please tell something about the market of smart contracts auditing? Is it bigger or smaller? Maybe the projects became bigger or something like this. What do you think about it?
It is a tough question because I know some smart contract security auditors are mostly doing like ERC20 or ICO audits. I can tell from our side that we do have a lot of big projects. You can see it on our website also. It's like big exchanges like 0x or like big frameworks, Aragon, or like big security tokens framework like Polymath. So I would say big projects are coming. So projects are becoming more and more complex, and they all need audits. So that's gonna happen. And I think less ICOs are like primitive ICOs are less popular right now. I also could predict that in future most complex things like state channels or like some plasma implementations or something even more complex, especially like crypto complex like ZK projects might be happening. So I can predict that this market will be more complex and bigger in that terms.
What % of your work is automated and what % is manual, would you say?
What is automated and what is manual?
Yeah.
We do have an automated tool for security. It checks like more simple stuff, and it is very useful mostly for smart contract developers, especially if they are new to field. And this is very common because lots of projects are, as I told, started from traditional software and just started doing smart contracts. So it's very useful for them to have like all the simple stuff, like the guidelines, and find some invariants like integer overflows or something. It's very good for that, and it's hard to find it manually because like reading all the small things manually is harder. But we do have a lot of things like most of the audits, like 90% I think, and bugs are if project has a good quality is founded by manual auditing because. Because most of the bugs are logical, and you can only find logical bugs manually. So I'd say this is the most important part. Thanks, everyone.